Welcome to SMART Photonics, the proud integrated photonics foundry. Today, we're excited to take you on a tour of our production facilities. Experience firsthand the entire journey, from design enablement to test and measurement, as we delve into the production of next-generation chips. Come along as we dive into the world of photonics innovation and witness how we bring your innovation to life. Here, in the Design Enablement office of HTC 37, we are hard at work translating the customer's needs into mask designs, serving as blueprints for the layers of the chips. By placing and specifying components like waveguides and lasers, we ensure our customers get the building blocks they need for their specifications. Here, we observe one of our team members suiting up. Every detail matters. He dons a clean room suit to prevent any particles from contaminating the environment. These steps are essential in maintaining the controlled conditions that are vital for our photonic manufacturing. Step into the epitaxy chamber. Epitaxy means vertical order and is the process of crystalline growth onto wafers. Inside these crystalline layers, light can be generated and manipulated. The layers are grown from gases in an under-pressure atmosphere at high temperatures, with atoms joining the surface one by one to create an accurate layer composition. In the PECVD chamber, oxide or nitride layers are deposited onto the wafer. This process creates thin layers for passivation, isolation, or pattern transfer purposes. While pattern transfer layers are sacrificial and are removed during processing, passivation and isolation layers are part of the end product and ensure enhanced lifetime and increased design flexibility. To create the microscopic patterns required to make integrated circuits on wafers, optical lithography is applied. We work at scales as small as 1/1000th of a human hair, so state-of-the-art lithography equipment is a must. Here, a resist is first applied onto the wafer. Next, the pattern is transferred to the resist layer using UV light through a mask. Then, the pattern can be transferred into the semiconductor in subsequent steps. After creating layers and patterns, we move on to etching away specific areas. We distinguish two types of etching: wet etching, which utilizes liquid chemicals, and dry etching, by employing gas-based techniques. Dry etching is performed through reactive ion etching, RIE, in which the ions remove semiconductor material both by reacting to form volatile chemicals as well as scattering away material through the high velocity with which they impact on the wafer. In wet chemistry, the wafers are immersed in a liquid bath in which a chemical reaction dissolves unmasked parts of the wafer. Metal contacts are deposited onto the wafers to allow electrical connections to the device. In the metallization area, various metals, like gold, are deposited onto the wafer using evaporation and sputtering tools. After metal deposition, excess metal is removed again. We do this to make electrical connections to the outside of the chip. Every step of our production process is closely monitored and inspected to ensure the highest standards for our customers. In the test, measurement and reliability area, end product performance is carefully inspected and measured to ensure optimal performance throughout the entire lifespan of our chips. Finally, we find ourselves in the scribing and cleaving department. Technicians ensure precise scribing, cleaving, and coating, completing the production from wafer to chip before they're packaged and shipped to customers worldwide. For instance, to make high-speed connections in data centers, sensing purposes in self-driving cars, or structural health monitoring for buildings and other structures. Thank you for joining us on this tour of SMART Photonics. Together, we are shaping the future. SMART Photonics, bringing your innovation to life.